Good. Talkers. So today's notes are going to be on your own. Okay? So the worksheet that you picked up, the yellow worksheet, that can go away. That needs to be done by Tuesday. Okay? So we want that worksheet done by Tuesday. But that can go away, and then you can focus in on today's notes. There will also be a video for you to watch prior to class next week, Tuesday, on circular motion. Okay? So we will have it posted this afternoon, and then you can watch it at some point in time and take notes on it before Tuesday's class. Okay? So we got that all going on, which is great, grand, and wonderful. Hold on. Put that one in there. So that's the warm-up that I wanted. So my question to you is, what is the measure here from yesterday? What is the measure here of the central angle theta in radians? If my arc length here is 20 Smarties and my radius here is 10 Smarties, what is my central angle in radians? 2 radians. Because I went 2 radii. Radii is the plural of radius. When we go on the arc, I would go 10 for my first radius, so that's 1 radian. Then I had to go another 10 to get the full length of 20. So that means that my theta here is 2 radians. Okay? Questions, comments, concerns, clarification. Today, what we are going to be doing is we are going to be focusing in on converting radians to degrees and degrees to radians, going in both directions. Okay? My question to you, and this actually goes back to yesterday, my question to you from yesterday is, how many degrees were there in one complete revolution of a circle? 360, right? And we discovered yesterday that there was how many radians in one complete revolution of a circle? 6.28, but we called it 2 pi. Then what we did is we said, well, let's make a ratio based off of those 2 equal things. And so we said 360 degrees over 2 pi radians. Well, that reduces down to 180 degrees over pi radians. Or, if we liked radians on top, we went pi radians over 180 degrees. That's all from yesterday. And we'll get back to those here in a minute. Okay? Now, those of you that have had a science class at some point in time have probably known the factor label method. Okay? So if I want to convert 6 feet to inches using the factor label method, I would then multiply by 12 inches over 1 foot, because those are equivalent. And so we're multiplying by 1. Right? But the cool thing is, in the factor label method, is these labels go away, because I got a foot on top and I got a foot on the bottom, so then those go away. Those cross each other out. Okay? So all I'm left with is inches. Right? So 6 feet is 72 inches. Well, with converting degrees into radians or radians into degrees, we do the exact same thing. The only exception is our factor label, whichever one you want to call it, that's equal to 1. Like here it was 12 inches to 1 foot. That's equal to 1. These two green things up here, that's your conversion factor. The first one, the left one, is if you're converting 2 degrees, or I should say 2, if you're converting into degrees. The right one is if you are converting into radians. So those are the two that we use there. So for instance here, 90 degrees, okay? So if I want to convert 90 degrees into radians, I would multiply, let me go back up a little bit. I want to get rid of my degrees, so my degree has to be on the bottom. And now this degree cancels out that degree, and I'm left with radians. Now, how you multiply fractions is how you multiply fractions. Okay? If you're a multiply straight across type of person, if you're a divide first type of person, totally up to you. We should end up in the exact same spot in the end. So this would be, if you multiply across, 90 pi over 180. Which 90 can be divided by 90, 180 can be divided by 90, and that would just leave me with pi over 2. So, so 90 degrees is pi over 2 radians. Which, if I go way over here by my good friend Lindsay, okay? So 90 degrees on the unit circle is right here, which is also pi over 2. So that's how we got it. Okay? Now, you might want to write down where is it?
Pi is right behind natural law.
There it is. Don't keep. You might want to write down 1.5707963327. That's ugly, right? Because that's rounded and all that fun stuff. Pi over 2, clean, pretty, nice. Okay? Whenever possible, leave it nice, clean, pretty things. Okay? Which means you're going to have to get to know your inner fractions. Okay? So convert at this time 315 degrees into radians and 210 degrees into Oh, we'll come up over the wind goes sweeping across the plain. So let's go by 9 first. If I divide that by 9, that gives me 35, I want to say. Yeah, pi all over 20. Divide by 5 gives me 7 pi over 4. Yes? Check it on here, 315 and 7 pi over 4. Yep. And we would leave it at 7 pi over 4. Because that's nice and great. Yep. 210. First off, I would get rid of the zeros. Then they can both be divided by 3. Leaves me with 7 pi over 6. Yes? Love it. Okay? Love it. Convert radians now into degrees is what we're going to do. Okay? So if we convert radians here into degrees, we do it the same way, except now we're starting with more than likely, I would say 7.5 times out of 10, you're going to start with a fraction already. Okay? And that fraction is going to be in radians. Now instead I want to get rid of the radians, so I'm going to multiply by 180 degrees over pi radians, and that is going to get rid of the radians. The nice thing also is that the pi cancels each other out. Not cross multiply, still multiply across, so we would still have 180 over 6, which is just 30 degrees. Okay. You try numbers 2 through 4. I get 810 degrees for the first one. Okay.
How do you have 810 degrees?
How did I get 810 degrees?
No, not how you get it, but like how? It just goes around.
Yeah. Yep. Nope, it just goes over, it goes over on top of itself. Yep. Yep. So it goes around, twice, and then another 90 degrees. Well, 2 1/4 times. Now, on this one, the nicitude, or it's not so nice, I should say, because that's going to be the exact 1. .89?
That's rounded.
I go 3. Agree? 887. We would tell you in a case like this, we would tell you if we wanted it exact. If you're going to use it in the problem going forward, you know what I mean? If this was just like the first part that you had to do, and you wanted to use it going forward, then I would keep it as 540 over pi. Because the earlier you round in a problem, the worse off you are. Okay? But if this were just a straight up converting type one, we would tell you what we wanted it rounded. Okay? Same here then with 1. And this we got yesterday, 57.296. Okay? Which we discovered yesterday. Okay? Now there's one additional chunk to degree measures. Okay? Because of those last two. It's not so clean to say 0.883 or 0.52956 or something like that. Okay? So the extra part is, there we go. For some reason the extra one didn't transfer over when we redid this. So anyways, so 1 degree is going to be 1/360th of a circle. Right? Because if it's 360 degrees all the way around, okay, you slice your pizza into 360 different parts or different pieces, 1 degree is going to be one of those. Okay? 1 minute, this is called a minute, is 1/60th of a degree. Okay. So a degree, that 1/360th can get divided into 60 equal pieces or equal parts. So we got that. So what would that be? 216, 21,000. So a minute is 1/21,600th of a circle. Okay? And then there's seconds. One second is 1/60th of a minute. Okay? So we'll put that right on here. So this is 1. This is 1. 1,296,000th of a circle. Okay? Or 3,600 seconds is equal to 1 degree. Okay? Now, higher level mathematics don't like decimals because they're, not as pretty. Okay? So higher level trig, I should say, like degrees, minutes, and seconds. DMS is what we like to call it, degrees, minutes, and seconds. So we are going to work now for the last 10 minutes here on converting from degrees, minutes, seconds to decimal degrees, or from decimal degrees to degrees, minutes, seconds. It is relatively easy. Okay? Because the nice part is that the degree measure, so in this case, the 245 degrees that we have there, that's going to be always there. That's your starting point. So you're going to have, if it's 245 degrees, 10 minutes, you're going to have 245 degrees. Okay? Point something, something, something. If it's 98 degrees, 17 minutes, you're going to have 98 degrees, point something, 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 something. Okay? That's the nice thing. Then, what you do is you're going to add to that this part. Well, this part is the minutes. But if I want to add to the degrees, I've got to convert minutes into degrees. So I'm going to divide that by 60. If it were seconds, I would divide it by 3,600 because I need to be in degrees, minutes, and seconds. Okay? Or I need to be all in degrees, I should say. Okay? So, once you get all that done, then you can add these all together. Well, this one right here is 0.166667. So this would be, and we usually round to 3 decimal places. So in degrees, minutes, and seconds, it's 245 degrees, 10 minutes. In decimal degrees, okay, that's what we call the other one here, decimal degrees, it's 245.167 degrees. Okay? Those two are exactly the same. Or I shouldn't say exactly the same. They're one's in degrees, minutes, seconds, one's in decimal degrees, but it represents the same. Okay? You try now converting 148 degrees, 16 minutes, 25 seconds into decimal degree. So we're going to start with 148, right? Let me move this up so people can see it over my big fat head. Okay? And then we're going to add to it our minutes. So that's going to be 16 over 60. And then we're going to add to it our seconds. That's 25 over 3,600. Okay? And so 16 divided by 60 is going to be, this is 0.26667, and 25 divided by 3,600 is 0.0069444 so on and so forth. But you can type it all in as one fraction, okay? And so if we do that, 148 plus, open parentheses, 16 divided by 60, close parentheses, plus, open parentheses, 25 divided by 3600, close parentheses, equals, I get 148.273,611. 1. Rounded to 3. Yes? Yay! Okay, quickly, because I've only got 2 minutes. This is really easy to do, I promise. You'll pick up on this really fast. So decimal degrees to go into degrees, minutes, and seconds. Okay? Here's the deal. Shabam. 345 is where we start, right? Okay? So that's going to be 345. And then I'm going to forget about that. So I'm just going to go with 0.12. Right? I need to convert that into minutes. What do you think I'm going to multiply by? 60. So I multiply that by 60. 0.12 times 60 is 7.2. So now this becomes my minutes. Right? And I drop it. So that leaves me with 0.2. I need to convert 0.2 into seconds. No, because this is in minutes, so what, Reed?
Just 60.
Just 60. 42? 0.2 times 60 is 42? 12 I like better. And that is my seconds. So this in degrees, minutes, and seconds is 345 degrees, 7 minutes, and 12 seconds. Okay? We can probably do this one in 32 seconds. What's my degree part? 215. Okay? So then we've got 0.63 times 60, right? 37.8. So that's going to be 37 minutes. 0.8 times 60 is 48. 48 seconds. Then you would round that one to at most the tenths. The seconds you would round to at most the tenths.